Alright folks, here we are again with another metalworking video. I haven't learned how to edit, so we're going to try to do all this in one take, and so we're going to have to move the camera around a little bit. And I haven't really rehearsed exactly what I'm going to say, so I'm probably going to trip over my words a little bit. But there was a question about why when you're rolling with a slip roll or an initial pinch roller, you get the flat section before the roll starts happening. And I got a little demonstration here before we move over to the slip rollers. We're going to pretend that these are the slip rollers, and we're going to pretend that my finger is the back roller, which actually the material rolls around. Now if you take a look, when the material rolls through, it goes a long ways before it hits that roller. So then when that roller is set so that it makes the material bend up, you can see that you've got a straight area here before the rolling actually starts happening. So and the roller doesn't move like my finger, but you see what happens here. You get this straight area from here to here where it had to pass through, and then it starts the roll. And then as it continues on, then you've got a continuous roll. Well, one of the ways to eliminate this is once you roll all the way through, you can come back, roll it in the other direction, and then get rid of that. I'm sorry, get rid of that roll on the way out. So you can run these through and just keep swapping back and forth until you get your desired roll, and that will help eliminate it. But metal has a memory, which we'll talk about a little later, and it won't completely eliminate it. It'll make it smaller, it'll make it less, but it won't completely eliminate it. So now we're going to go over to the actual slip rollers and talk about adjusting them. And so here's the slip rolls, and try to get in here as close as we can. This is pieces of, I believe, 24 gauge black iron, and I've got several pieces here so we can play with it. And we'll talk about adjustment a little bit of the slip roll. You want them, these are called initial pinch rollers, and these rollers here pinch and pull the material through. You've got a lot of slop right here with this over here, which allows you to take, if you roll an entire circle, this allows you to take the material out. No matter what you do, you're going to end up with a little slop there. You've got adjustments here to help take that out, but after years of wear, you end up with a little bit of slop in here no matter what you do, if you still want to be able to get it out. So you have to take up for that slop. So you'll see as I put the material in here where I can get it in and out easily, as I tighten up, you'll see this handle move up just a little bit, and so there we're tight, and we've got all the slop out of this. Now there's no more slop in this handle. So I have to back that out. When I move over here to the other side, again, we're backing it out so we slip in there, and it's a feel thing. You get to the point where it just barely pinches the material because you don't want it to crease the material. You don't really want to be able to like pull it out with your hands, but you don't want it to make lines in the material either. Then, since you moved that up, obviously you got a lever moment here, so you're going to have to work back and forth a little bit and play with it so that you might have to move back and forth and get a feel for this. There you go, that feels pretty good. So now we've got this set up perfectly parallel, and we'll go ahead and just run this through. Actually, let me move the camera. I'm going to raise it up and move it around a little bit so that you can actually see what happens when the material rolls through. Alright. As you can see, your back roller, which does the rolling, which actually does the bending up, is back a pretty good ways. So we have them adjusted so they're parallel. So this is still parallel because we're just doing a simple bend. Now you see the material from the time it pinches, which would be the very bottom of your contacts, it's got to go to there before it ever starts bending. So now you've got that flat spot that I was talking about. And that flat spot starts right there. Now I'm going to go ahead and do this one more time so it's a little more pronounced and you can see it. The idea is that we're going to talk about how to get rid of that flat spot. Now, there it's probably a lot more pronounced. You can actually see a crease in the material where when it got to that point, it starts bending it up. So now one way to eliminate that, let's say we're going to bend this to a U, 180 degrees. You can turn your material around and run it through. Now when it gets to this point, it's going to continue rolling that out, and it eliminates quite a bit of that, but it doesn't eliminate it completely. So let's see, we're going to run this up again. Okay, and we're going to turn it around. And we're not quite 180. I'm going to sneak up on it just a little bit more. We're going to do that. We're going to turn it around, run it through the other way again. And that gets you pretty doggone close. And you can see that most of that is gone. Matter of fact, I've got to look. There you go. I can see right there where the bend started. So it's almost eliminated, but not completely. To talk about, well, before I move this brake, I'm going to talk about, roller, I'm going to talk one other thing. We did this in multiple passes. Now there's elastic properties to metal where you can bend it to a certain point and it just springs right back to where it was. But if we squeeze this thing farther, it's going to plastic deform and it'll stay where you put it. Now this plastic form is changed every time we do it. You've got the same amount of spring, so when this thing was flat, you can spring it up to a certain point and it'll stay. Then you go past that and it stays there. Well, now your yield point starts here, so you can spring it that same amount again and it doesn't go anywhere until you go past its plastic deformation point. So the yield points are in different places on the metal or metal memory. So I haven't moved the adjustments on here, but we're going to take another piece that hasn't been bent and we're going to run it through the rollers. And if we look, it's going to make a wire out of it. Generally speaking, that one will end up tighter. The repeatability isn't what it usually is. Let's see here. Alright. Well, I'm going to turn around, run the other half of it here. Do the same things we did, and you will see it's slightly tighter. This one will drop in to here, but this one will not drop into that one. So the repeatability is because of the plastic deformation is different. And usually the thicker the material, the more pronounced that will be. So now, getting rid of that flat spot, that initial flat spot, there's a couple ways you can do it. If it's a big heavy sheet and it's all the way across here, you could put the sheet in, just barely get it in and come out here and push down on that sheet all the way across, and you get a start right here like this, and then when you feed it through, you already have that bend starting at the beginning. The other way to do that, I'm going to come back here, I'm going to do the same thing we did before. We're going to back it down and work our way up to the desired roll. But the other way to do that is to start from here so that your back end is supported already, and actually run your rollers backwards. So you've started your roll from the beginning. Now you've got that roll all the way out to the end without a flat spot. Now you started there, and you can turn around and come back the other way, and you can make your roll. Let's come back. Oops. Come back to here and do your roll. So now you've got a roll that's pretty doggone consistent all the way through. I believe my rollers climbed up a little bit when I did that. Now we're gonna go back here, start this. My gears bind up on this roller, so it's not as consistent as it could be. what I'm going to do now is run everything from the back side, so hopefully we're a lot more consistent. But again, we've got that plastic deformation problem, and you see that it rolled a lot tighter. But we don't have the straight ends on this. That completely eliminates that, having that straight end. Now, I'm going to talk about that metal memory, and I hope it works on this, because this stuff seems to be pretty dead soft, not a lot of springiness to it. Let's go. We'll lay this back down. We're going to try to flatten this back out. So I'm actually going to roll the material back out flat. Now we're to this point. I'm going to back it down more. So hopefully this is going to be an explanation of plastic deformation, or what a lot of people call metal memory. Alright, we're still getting a slight roll up. And what we're after, I'm going to try to get it so that it rolls perfectly flat. Still roll it up a little bit there. Not as much in that direction. So we're getting close to what I'm trying to show you. A little less. This stuff is pretty doggone dead soft. Okay. Here I managed to get that piece of material pretty much dead flat. Now we're going to remember what's up and what's down. Now we have a curve. You can see the ends are away from the ruler. I can rock the ruler. Alright, so we ran it through this way. I'm going to turn it over. I'm going to run it back through. And now the material is dead flat. That's from the metal memory, that's from the plastic deformation. That's what causes that second one to roll tighter. The fact that you've gone past the plastic deformation, or past the elastic and gone to plastic deformation in one direction. So that's the metal memory. That's the reason you won't get, if you sneak up on the roll and then you try to take another piece and roll it through again, it's going to end up tighter. Not by much in this case, but if it's a thicker section, it's going to end up a lot tighter. So that was one of the things I wanted to get to and explain the difference again. We're going to look at those two pieces that were ran through, and they come up totally different. Alright, next thing I wanted to show on using the slip rolls is if you're going to do a cone, there's a way to do the cone. And this is about the same material thickness. I want this one so that I can actually work it and back it back out. I don't want it to pinch quite as tight as what I had it before. So play with the adjustment a little bit. There we go. Alright. And we have a guide. Simple piece of angle iron with a tab welded on the end of it so I can clamp it on. And I'm going to clamp it on right here. And then I'm going to put this edge right up against that angle, and I'll probably move the camera around so you can see what I'm talking about there. Hopefully that's still looking at it. Alright. So you're putting it right up against here, and you get your piece started. We're going to run our back roller up so that it actually rolls this. And since we're trying to do a cone, you have to remember that this part of the cone is going to bend less than this side, because this is going to be a tighter radius than this. So now your back roller is on an angle. Alright, so here we go. I'm going to try to just let go of it now and see what happens here. You'll see that I'm not guiding anything. It's just guiding itself right through the rollers. So now, let's go ahead and tighten it up a little more. Do that one more time. And again, I'm not touching it. And it's just making itself a nice cone shape. We'll run it up a little tighter. I like to sneak up on my shapes. Yeah, I went a little aggressive right there. But there we go. Nice cone, and it guides itself right through there, rather than having to work your way around by hand. So there's a little tip for you on making cones. So let's see. The other thing, I have another neat little trick. This is going to involve not only the rollers, the slip rolls. It's also going to involve the sheet metal brake. Go ahead and get this set up. Again, feeling for that, taking all the slack out, getting this set up. This is 50 thousandths thick. It's 5052 H3 aluminum, which is actually very difficult to work with. 3003 H14 would be a whole lot better, but I think we're going to be able to show you a neat little trick here. A lot of people say you can't do compound curves on a flat roller. I'm going to use a little bit of brute force here. And we're going to run this thing through crossways from what we just ran it. I'm going to do this several times, and we're going to do it pretty aggressively. I'm going to crank that back roller up. We're going to have to put a lot of pressure on here to get this to go through. And even more pressure now that we did that. Okay, I'm going to do that. A few times. Now we're going to back these off. Slowly start backing the back roller down. So that we get this less and less. And we'll do a couple passes in each direction. You can see it's getting a little easier and easier to get in there. And the reason I'm showing you this, one of the reasons, is a lot of times doing a very low crown panel like a door skin, what you would spend a lot of time doing on an English wheel to get that crown, you can work in with the slip roller. Sure hope this demonstration actually works. Things work until you try to video them. That's what I've found. Alright, so we're going back and forth here. I'm going to keep backing it down. At this point, do a little bit of hand working. I'm going to take it over to the workbench. And if everything is just right, take this, Sorry about that. You put it down on the bench, you'll see that all four corners are down, all four edges are down, but you actually have a crown this way and you have a crown that way. Maybe I can set it on a 45 degree. You'll see that there's crown that way and there's crown this way. That's a compound curve, that's metal shaping. Okay? Without an English wheel. So that's a way to get a low crown in a door. Now it's definitely a stressed panel. People that you know want to make a panel that's completely stress-free, what you can do at this point is, now if you got the height, the rise and everything that you want, then find your wheel on the English wheel, find your lower anvil that matches this, your almost, you know, your slightest crown. Go ahead and just wash over the panel one time and you've got a nice low crown panel without a bunch of creases. So now, fun thing about that, let's see if I've got this so that you can see. Maybe I'll drop it down a little bit. There we go. The fun thing to do with this, I have my stop set on here so that my bending leaf is on an angle, slight, probably about 6 or 7 degrees. There's a stop back here, and I have the stop flopped over on the rod so that it can go forward, but it can only come back to a certain point to maintain my angle. Fun thing you can do with this is, now that you have that shape in there, you can use this like a press brake. And I'm going diagonal across here because I like the pattern. And I didn't draw any lines on here, I'm just doing this as a demo. Demos are fun because they don't have to fit anything. But now, by doing this, you can make a really nice quilted pattern. And this quilted pattern, once you lay it, get the shape back into it, take this back down almost flat, and I don't know how well we can see this, but now you've got this quilted pattern, and it is literally puffed up between each one of the, and it's like a stuffed quilt. Really neat way to do that. So you can either make a low crown or you can make a nice quilted panel. I've made dashboards like this where out of one sheet of metal where the top of the dashboard is flat, it rolls around, it goes down to the instrument panel, and then from the instrument panel section, the flat section, from there back down, I use this quilted pattern on it, and really makes a nice looking dashboard. So that's a little trick there. One of the other things I wanted to show while I'm here on the break, and while I've got this set up, I'm going to go ahead and make it a little bit steeper. Set my stop, and if you're trying to make a squared around, or if you're trying to make a fan shape, I might have that a little too steep. Here's a neat little trick for you. If you're doing a piece that needs to be round out here but coming to a certain point here, I am going to leave that point in the same spot all the time. Just pull it down, bring it around, pull it down, keep that point in the same spot, pull it around. And the more of these you do, obviously the more of a fan you'll get. And but now you've got straight sides here but a curved piece here. So if you're doing something that needs to be squared around, this is one way to do it. and it makes it just all one motion. You're not having to pull it down, clamp it all the way, and then rock your piece up, and then do it again, move it, rock it up. It's just one quick motion. And you get it set up right. Let's say you got 9 bends at 10 degrees each, you'll end up with a 90-degree bend. And that's usually what I end up doing on a squared around, is about 9 bends at 10 degrees each, and that gives you your 2 halves will be 180-degree bends, and 90 degrees per corner. And so you'll do 90 from here, and then you'd switch over to the other corner and work your way around. But anyway, that just eliminates a lot of motion. It eliminates making a complete clamp down and then bending it and then coming back. And then if your bends aren't consistent, if you stop in different places different time, you won't have a nice continuous radius. This way every bend is exactly the same. So we migrated from slip rolls to brake, but hope you got something out of it.